Pre-flight 101, the course that will give you wings. 5. Aircraft systems and structures. 5.1 General aircraft systems and flight controls. In this section, we're going to be going through the different systems of the Cessna 172. As you might remember from previous lessons, there are many kinds of Cessnas coexisting today. With so many variants of the same model, it'd be extremely difficult to learn by heart all the specifications about them. That is why, in this chapter, we will take a look at the models November, Romeo, and SP. The system in the model November is a good representation of the systems you might find in the older models, such as the Mike, the Foxtrot, or the Hotel. On the other hand, the Cessna 172 Romeo features an injection engine as the main chains, and in some models it features glass cockpit avionics. In this case, we are talking about the Garmin 1000. We will take a look about this later. The SP model is the most advanced model Cessna has ever developed till today. We will comment with this model also the differences between diesel engines and gas engines. So, to sum up, November Cessnas refer to the older models with carburetor engines and basic avionics. The Romeo Cessnas refer to the new models but still running on injection engines, featuring newer avionics, and the SP type will be covering the most advanced technical developments such as second generation glass cockpit or a diesel engine. However, I really encourage you here to always check your manuals and documentation before flying to make sure which airplane you are going to be on, right? So this is kind of a bit of a disclaimer here from this course. We have taken the Cessna 172 November, we have taken the Cessna 172 Romeo, and we have taken the Cessna 172 SP. Just as an example of the older, the new and the newest models you can find. This doesn't mean that every Cessna 172 Romeo has glass cockpit, and this doesn't mean that every Cessna 172 SP is fitted with a diesel engine. I think we have already talked about this, but for the sake of this course, we're going to do it this way so it's easier for everyone to understand. This lesson refers to the section 1 of the POH, the one we're going to be seeing right now, generals, okay? And you can refer to it for more information. Let's begin now with the general measures of the Cessna 172. 1. Structure measures. The Cessna 172 November is the one we are seeing right now on the screen. Seems to be a bit shorter than the rest of the Cessnas, right? We see a length of 8.23 meters in the Cessna 172 November. That is the same as the Cessna 172 Romeo. However, the Cessna 172 SP is slightly longer. However, this is not really a big deal. The wingspan is about 11 meters. This measurement is really important, okay? It doesn't matter which model you are taking a look at. For example, this one is the Romeo, that is exactly 11 meters. The November is a little bit less, 3 centimeters less. That's not really big deal. And the SP is 6 centimeters more due to the wingtips. Okay, the shape of the wingtips is gonna give it those extra 6 centimeters. But as I say, no big deal. The most important thing you need to know is that the taxiway width you need to taxi with this aircraft is at least 11 meters. Okay, in the case of the SP, at least 12 meters, right? So just remember, your minimum taxiway width is gonna be 12 meters. The height, it's around 2.5 meters, a little bit more. As always, this Cessna 172 November is a little bit smaller. And the biggest is the Cessna 172 SP, but the difference is not that big. The wheel-to-wheel distance is exactly the same. The landing gear of the Cessna 172 is one of its most characteristic things. so the shape hasn't really changed since the oldest models. So in the November, in the Romeo, and in the SP, the wheel-to-wheel distance is same in all three. Okay, so these were the measures of the Cessna 172. Now we're just gonna take a look at the descriptive data of the Cessna 172. So as we can see in the table, the descriptive data is also part of the section 1 of the POH and refers to information we can find in section 1. Okay, it talks about the engine specifications, the fuel capacity, the oil capacity, and the propeller specifications. The engines. Well, the most important difference from the three models is probably the engines. As we said, Cessna 172 November is fitted with a Lycoming 0320 H2AD 160 horsepower at 2,700 APM, and it's a carburetor engine. Okay. Cessna 172 Romeo is a Textron Lycoming IO 360 L2A with 160 horsepower, same power as the Cessna 172 November, but at lower RPM. 2,400 RPM are enough to produce this 160 HP. And the jet fuel or diesel fuel engine we're taking a look at in the Cessna 172 SP produces 115 horsepower at 2,300 RPM. Okay, we will take a look at them. We will take a look at the difference in the engines section from this course. The fuel capacity. The fuel capacity of the Cessna 172 November is 43 US gallons, from which only 40 are usable. There was a major increase in this capacity in the Cessna 172 Romeo, increasing almost 13 gallons. And in the diesel one, this capacity is also reduced to 47.6 and only 44.6 usable. This is because jet fuel seems to be much more efficient than gas. So basically you don't need that much fuel, and fitting bigger tanks was not the best idea because you had to fit extra fuel pumps, and well, it just didn't fit that well in the wings, so they decided to cut the capacity just by a bit. The oil capacity, it's just 7 quarts in the Cessna 172 November, 9 quarts in the rest of the models. In the newer models, it's going to be 9 quarts. And the propeller specifications basically are going to be the same, 74 or 75 inches for both the Cessna 172 November, Cessna 172 Romeo. Usually these two planes fit a 2-blade propeller, okay, only 2 blades. However, the jet fuel with the TAE 125 engine, this is gonna fit a propeller that has a diameter of 190 centimeters, and it's gonna be 3 blades, 3 propeller blades. The weights. The weights are also a bit different, and here I really want you to exercise caution, okay? Always look at your manual. These weights are just, let's say this way, the basic weights, right? Your company might have different weights, your flight training office might have different weights, your aircraft might have different weights. Always refer to the weight and balance section or to the weight and balance documentation in your organization for these topics, okay? This is just for you to see that there have been changes in the Cessnas, but this data is not to be taken for performance or weight and balance consideration. Anyway, as you can see, the maximum takeoff weight is 2,300 pounds on the Cessna 172 November. That was increased in the Cessna 172 Romeo and was increased again in the Cessna 172 SP, which means that basically we are being able to take off with more weight with newer airplane than older airplane. Also, you have to take into account that the Cessna 172 SP with the diesel engine is going to be heavier than the Cessna 172 November. Okay, so it is logic that the maximum takeoff weight is going to be bigger than in the Cessna 172 November. The maximum landing weight is going to be the same as the maximum takeoff weight in the 3 airplanes. Okay, this is something to really take into account for the operation of a Cessna 172. The Cessna 172 is an aircraft that has the same limitation for takeoff than for landing, which means that if you're able to take off, you're going to be able to land. Okay, that's really important to have in mind. Not every airplane is like that. For example, talking about a Diamond DA42, that we will be featuring another course on that airplane as well. The takeoff weight is slightly higher than the maximum landing weight. Therefore, if you take off at maximum takeoff weight, you would have to burn some fuel or lose some weight all the way to be able to land under the limit. Okay. Anyway, getting back to this information, the maximum zero fuel weight, we don't have a limitation in the Cessna 172 November as the manual is really old. However, in the Cessna 172 Romeo is 2,457 pounds. So we can actually fit 7 more pounds for ramp than for takeoff. Okay, just a normal number. There's no big difference. We will go through what maximum fuel zero fuel weight means and what it is for in further lessons. The basic empty weight, this is basically the weight of the airplane without crew, without baggage, or without fuel, basically empty. As you can see in the Cessna 172 November, it's 1,393 to 1,419 pounds. In the Cessna 172 Romeo, the weight is slightly higher. It goes up to 1,639 pounds. And we don't have information about the Cessna 172 SP because of the engine fitting. Depending on the engine fitting, the standard empty weight or the basic empty weight is going to be different. However, as I said, always check your manuals when regarding to weights, because this is just descriptive data. This is just for you to know which Cessna is bigger. So always refer to your performance checks. Now, as the third point, we are going to be talking about the fuselage. Okay, the fuselage, this is what you get in the manual for the fuselage. I think the most important thing from these 2 pieces of text are these. Okay, the structure of the Cessna 172 has a semi-monocoque fuselage. Okay, which means there are sheets of metal forming a bulkhead, stringers, and a skin. Okay, so not only the skin supporting the loads on the fuselage, but also some stringers. Okay, the stringers are metallic lines going from the front to the back of the fuselage that are gonna give those that extra strength to the fuselage. Okay, that it wouldn't actually have if it was only skin, right? Now, the main landing gear attachment has a couple spars attached at the base of the rear door posts. Okay, the gear attachment is attached right to the forgings of the bulkhead. Okay, this is really important. Also, 4 engine mount stringers are also attached to the forward door posts and extend forward to the firewall. This means that just in front of you, there are going to be 4 engine mounts supporting the engine. So, in front of you, in front of the cockpit, in front of the instruments, there's going to be a firewall. As we will see in fire protection systems, the firewall is basically a piece of metal that is going to be doing 2 things: protecting the cockpit from fire or heat coming from the engine, and also supporting the weight of the engine. In this case, the engine is going to be supported by 4 engine mounts. Now, this is really important in the wings. Okay, we're going to be talking about the wings also in this section. They're integral fuel tanks. Okay, they are constructed of a front and a rear spar with foam sheets, metal ribs. Okay, so basically the fuel tanks are inside the wings. Okay, inside the wing, everything is full of fuel. Okay, that's where we keep our fuel, inside of the wing. Aluminum skin. As we talked about in section 2, since the Cessna Model 140, Cessna hasn't changed the material or the shape of the aircraft much. The material of the Cessna 172 is aluminum. Okay, basically all the structure is made out of aluminum. Rivets are also aluminum, fuselage aluminum, tail, empennage, everything is aluminum. Now we're going to be talking about the flight controls. This is the fourth section. As you can see from this drawing, the Cessna 172 has the aileron control system moved directly with pulleys from the controls. So you have your flight controls here. You have two of them. You have the right side flight controls, the left side flight controls. You can call them a yoke also. They are both connected to the same bar, which means if you make an input from the left, the same input is going to be going on the right. This is really good for instruction, guys, because that way if you're doing something wrong as a student pilot, your instructor is going to be able to correct you. Okay, so both controls are going to be moving the same way. Then this metal bar is connected via pulleys. Okay, we can see two systems of pulleys, one going through the right of the fuselage, one going through the left of the fuselage, and they go through a crankshaft right over our heads. Okay, so over our heads we see these wires, these stringers going right for the ailerons that are in the outer section of the wings. So when we turn our control, one of the ailerons is going to get deflected down and the other aileron is going to get deflected up. This is to counteract adverse yaw. Now, why are the ailerons in the outer trailing edge of the Cessna? Well, they are in the outer side to create a bigger momentum. Okay, the outer it is, the bigger the control you get. If we would fit the control here, the aileron here, we wouldn't get that much control. So we want the ailerons to be out. Okay, in every aircraft in the world, the ailerons are going to be in the outermost part of the wing. So as I was saying before, one aileron is going to be going up, the other aileron is going to be going down. So which one is going up, which one is going down? Let's do the exercise. When we're turning right, we want the right wing to drop, right? Okay, if I want this wing to drop, this aileron has to go up to break the boundary layer and make this wing drop, okay? And this aileron has to go down to create more lift and raise this other wing. Okay? So again, if I want to turn right, my right wing has to go down. For my right wing to go down, I need my right aileron to go up. And I also need my left aileron to go down. Okay? Remember this, we are going to be using it in the flight control check when we talk about operational procedures. Now, also in flight controls, we have the radar control system. The radar is the flight control used to steer the aircraft in yaw in the normal axis of the airplane. So we have two pedals fitted on each side. Okay, we have two pedals, if you push the pedal to the right, your aircraft is going to turn to the right. If you push the pedal to the left, you are going to be turning to the left. Okay, so both of the pedals are also interconnected. So if you push one pedal, the person sitting next to you is going to feel that input. Okay, his pedals are going to be moving as well. This again is really good for instruction, because your instructor can actually give you inputs real time to correct your inputs if they are not correct or not enough input, right? These two systems are going to be connected via pulleys that go under the floor towards the tail. Okay, if we want to check that these two wires are working properly, the only thing we have to do is look for these cables in the exterior inspection, because they are going to be visible from the exterior inspection when we look under the tail of the aircraft. Okay, we will see this in the exterior inspection. Don't worry about it. Just think about the system for a bit. Also, the elevator control system. It works pretty much like the aileron control. This one's going to control the pitch. It's going to control if the nose of the aircraft goes up or the nose of the aircraft goes down. The same as with the aileron. Both of them are connected via this bar, okay, via the yoke bar. So when you make an input, the other one is also going to move. Then the movement is going to get transmitted via crankshaft, right? Crankpin or wires, right? It's going to be transmitted the same way as the wires or the cables from the rudder system, and it's going to go to the tail, connect to the elevator, right? That's going to make your nose go up or go down. Also, we have the elevator trim control system. The elevator trim control system is going to allow us to keep a constant pitch attitude without needing to be touching anything. Okay, so imagine you want to climb, you pulled your nose up, but if you didn't have a trim, you would have to be pulling on the yoke all the time, and that'd be really exhausting. So for this thing not to happen, we are going to be fitting a elevator trim control system. This system is going to keep the nose of your aircraft pointing up or pointing down, wherever you choose, without you needing to give it any input with the yoke. Okay. The trim is a tab that is located on the right hand side of the elevator, the trailing edge of the right elevator, and is connected via cables and pulleys to a wheel. Okay, there's a turning wheel. We're gonna see this in the instrumentation, in the cockpit, and in the procedure section many times, because the trim is one of the most important flight controls. But basically it's a wheel in the middle of the cockpit, right over the fuel selector, under the throttle and the mixture, that is going to serve pilots to reduce this workload and keep this pitch attitude constant, which is basically going to reduce the weight of the aircraft. This system is manually operated. Okay, there's also electrical trimming. We will see this in the avionics section. Now, secondary flight controls. We have the flaps. The flaps, as I said before, are in the inner part of the wing, in the inner trailing edge. This is so in case you have a failure with one of the flaps and one of the flaps goes down and the other one doesn't, the roll moment is not big and you don't lose control of the aircraft. Okay, the ailerons are always in the outer trailing edge of the wing, and the flaps are in the inner trailing edge of the wing. They are connected via cables, okay, and they are electrically operated. Okay, so we have a selector in the cockpit. It's like a switch, just like at home. I want the lights on, I flick the switch. Okay, it's completely electrical. The flaps in the Cessna 172 are completely electrical. So I flick the switch, an electrical signal is transferred to the controls, and the controls are going to move the flaps also electrically. Okay, so this system is a fully electrical system. This system was manual before, however it started to be electrical many years ago. As you can see, there are the general structure properties of the Cessna 172. Let's say somehow maybe the skeleton of the plane if you wish. We will take a detailed look at the outside when we talk about the exterior inspection. In the next chapter, we're going to be taking a look at the inside of the plane, instruments, avionics, and communication equipment. So this was it for now. Keep studying, try to think about the flight controls. I'll see you on the next lesson.